Thanks to Skillshare for supporting today's video. Hello maths fans, Dr. Tom Crawford here at the University of Oxford, and today I'm going to be making some mathematical art using fractals. The plan is for me to follow the Skillshare course, create stunning fractals with JavaScript and p5.js. I'll be honest, I'm not completely sure what that exactly means, but the images look incredible, so let's see what I can do. Skillshare is an online learning community with thousands of inspiring classes for anyone who loves learning and wants to explore their creativity and learn new skills. One of my favourite videos I've ever made looked at Mandelbulbs, which are a 3D rendering of the infamous Mandelbrot set. So when I saw this course on Skillshare, it seemed like a perfect fit. Maths, art and coding, what's not to love? I've just signed up for the course and I'm going to be recording the whole thing so you can all see my progress in real time. And if you'd like to try the course for yourself or any of the literally thousands of others available on Skillshare, then make sure you use the link in the video description or just head over directly to Skillshare and join using the code TOMROCKSMaths. The first 1,000 people to do so will get a 1-month free trial. Right, let's do this. Video 1, Introduction. So now I know what p5.js is. Tells me immediately in the introduction, which I like a lot. It is a graphics library that's going to be available online, apparently in a HTML file, which I think means it can run through an internet browser. Testing my knowledge here. So we're going to be drawing fractals based on Julia sets, which I'm super excited about because the fractal tattoo that I have on the back of my leg is a Julia set. So maybe I'll try and recreate my tattoo as a piece of art. Maybe. We'll see how difficult that is. So the instructor is giving a really nice outline of the course, saying we're going to start with a black and white Julia set, then we're going to add some color, and then we're going to zoom in and move around the fractal, which I think is going to give rise to the different pictures and videos and all the different artwork that I'm hoping to create. And all I need is a browser and a text editor, which sounds like my kind of level of coding, which is beginner. Right, so let's move on to the second video, which is called Drawing the Fractals. So first thing I'm going to do is actually download the text editor the instructor is using, and so therefore has suggested something called brackets and gives me really clear instructions of where to go to get that. So I'm just going to follow those instructions and basically do exactly the same as the instructor. Right, so I've installed brackets and now I've got to create the page, I think, where I'm going to be doing the coding and the editing. So I've just got to copy over a few commands. So let's just do that. It was telling me to create a new blank file, fantastic. And then I want to do doc type, which I believe I want to be HTML. So doc type. This is very different coding to what I was doing with Python, that's for sure. Doc type HTML. Okay, and then it's saying then write HTML, sure, and then something called head and body, right? So I want head, and we want body, and so I'm assuming the / maybe means to close the thing, I think. Would be logical. And then that's going to then be close body. Okay. And then close HTML. Right, yeah, that makes sense. Okay. Right, so I need to reference the location of this p5.js file. So the instructor is suggesting I use cdnjs. Seems like a thing. So I'm going to go there, cdjns. And we want to search for, what was it called again? p5.js. So we search for p5.js. I'm going to copy the script tag, and then I believe I'm just going to copy that into my script. He says, we shall see. Okay, so we're creating a canvas. So I guess this is like as an artist going to the shop and picking which size of canvas you're going to work on. So the instructor's gone for 500 by 500. I might go for the classic 1920 by 1080. Don't know if that's going to ruin my computer, but I'm going to try it. Okay, so there's a create canvas function within the setup. So let me just type that over. So create canvas, and then you're picking the dimensions. So if I do 1920 and 1080, boldly, and then we close that bracket. Okay, let's see. So we have to pick a background color, and it's done using the RGB numbers, which I love. I love RGB and that whole discussion around 0 to 255. Really cool stuff around binary numbers and how we code things on computers. So I'm very happy about this. So I need to pick my background color. So you just type background, and then I have to give it the 3 values, one for red, one for green, and one for blue. So let's see what the instructor is going to do, and then maybe I'll copy, maybe I'll do something rogue. Haven't decided yet. 10, 10, and 100 to get a darkish blue. Okay, so we're adding a no loop function, which apparently makes sure our web page does not consume too much CPU. I think the idea is it automatically generates an animation, and we're going to create a still, at least at this point, if I've understood correctly. So we'll add in the no loop function. Right, apparently the canvas should be ready, so let's run this. How on earth do I run this? That's the question, isn't it? Well, I'm going to save it first. Yes! There we go, I got a giant blue square. This is awesome. Okay, I have a blue square that seems apparently to be too big to fit in my internet window, but I like it. Okay, so I have my 1920 by 1080 sort of dark blue square. Well, not square, rectangle, which is very similar to what the instructor has, except they've got a square. I went big and went for the 1920 by 1080. But that looks good. Okay, so first bit of code, we're working. So we're starting by setting up the complex function. So we have f of z is equal to z squared plus c, where z is a complex number, and also c is a complex number that we're able to pick. And I know that as we change the value of c, you get different Julia sets. So the fractals are created through an iterative process. So we calculate f of z, get an output, which is z squared plus c, where c is this fixed complex number. And then because it's an iterative process, we take that output, f of z, that's our new input. So that's like our new z, and then we input that back into f. So basically we're applying f of z, then f squared of z, then f cubed of z, and you just iterate this process and keep applying f more and more times to the starting point z. Very interesting. So the way we're going to define whether you do or don't belong to the Julia set is whether through this iterative process, every time you output a complex number, we're going to take the modulus of that complex number, and if it's greater than 2, then it is not in the Julia set. But if the modulus is always less than 2 for continued iterations, then we say it is in the Julia set. So we pick a z to start, we keep applying this process. As long as it remains below 2, its modulus, we say this is in the Julia set, we're going to keep this point. If at any point the modulus goes bigger than 2, that point is not in the Julia set. And basically we try this for all the different values of z in the complex plane, and that gives you which points are and are not in your Julia set, and that gives you these beautiful fractals. Oh dear. Apparently we're now going to code everything that I've just been explaining. Scary. Interesting. So we're going to create a function which is going to determine whether or not a complex number, so we're going to give it 2 inputs, x and y, and it's going to return true or false whether or not it is in the Julia set or is not in the Julia set. So let's do that. So I want a new function then, don't I? So I want a new function which is in Julia set, is in Julia set, is, so it's capital on the I, is in Julia set, and then I want to do x, y, x comma y, and then it gives me an output. Okay, fine. Interesting. So we have to decide how many times to apply f. So we're going to define that as var, and then he's typed max times, and we're going to do, apparently we're going to do 100. So we're going to apply f iteratively 100 times, and apparently that's going to be enough to determine whether it is or isn't in the Julia set. Seems quite low to me, but we'll go with it. So max times equals 100, and then we're also going to scale the output so that it fits our canvas. Very clever. So var sx equals map, and then we're going to take x and 0 and width. So depending on the width I pick for my canvas, clever. And then apparently the Julia set function just considers small values between -2 and 2. So that's all we're going to look at here. Okay, so -2 and 2. Sure. Guessing we're going to scale y as well. So we're going to create a loop, a while loop, to run the calculation, the max times that we've set. So here 100. So we're going to then add the variable var I equals 0. It's going to be our starting value. And then we're going to run while, and we're going to say we're going to run it for I less than max times, and we're going to run it as long as it's less than that, right? Yeah, I see. We're going to do that, sure. So we need to know z squared, put that inside our while loop. And because we're using complex numbers, of course, we need to express in terms of x and y what the square of x plus iy all squared actually is. Some of you may know this if you've studied complex numbers, so there's a nice little explanation here, again, of the maths behind it. I'm really enjoying the mathematical explanations to go along with the code. This is really nice, really good way to do this. And you know, I love learning maths. So we're splitting it up into real and imaginary parts, I'm assuming just for ease of calculation. So we're going to define those. So var real equals sx times sx minus sy times sy. So we're doing the real part. When you square the complex number, it's x squared minus y squared. I guess there's going to be an imaginary part. Imaginary part is 2xy. Great. So var imag equals 2 times sx times sy. Excellent. So now we're defining c. So we did say a little bit earlier that what we're going to do is f of z is z squared plus c, and as you change the value of c, you get a different Julia set. So to start with, I'm going to use the same values as the instructor, just to make sure everything's looking correct, and then of course I'm going to have some fun and see what cool things we can create. So I'm going to say sx, the new output is real, that variable plus, what was he saying? We're going to do 0.35. And then I'm going to define the new y value to be imaginary, and then we're going to add, this time it's going to be 0.2. 0.2. Okay. Looks good. Nice. Clever. So this is just running one iteration. And so what we now need to do is set up the condition around the modulus. So this is doing one set of calculation for a particular z value, particular x and y. Now remember, for it to be in the Julia set, we need the modulus to be less than 2. Now, the modulus is the square root of x squared plus y squared. However, as the instructor pointed out, square roots are very expensive computationally. So what we're actually going to consider, because ultimately it's the same thing, is whether x squared plus y squared is less than 4. Because if it is, then the square root of that will be less than 2. So it's very nice. This is like our condition to check. So we're going to run through this calculation every iteration of f, and at each stage check if the modulus is less than 2. If at any point it isn't, then, or it's greater than 2, then we're going to return false, because that tells you that that point is not in your Julia set. This is it's really nice to see how this is coded, because I know all the maths behind it, but writing out the code here, this is really cool. So I want to say if sx times sx plus sy times sy, so x squared plus y squared, if that's greater than 4, then I want to return false. I think. Well, not flays, false, I think. And then, of course, if we don't have a false after running through this, then we want to return true. So it's saying, check it 100 times. If every time it's not outputting a false, then by default it outputs true, i.e. we are in the Julia set. So that needs to go outside of the while loop. So within here, I think, let's see, return true, I believe is where I want to put that. Oh, on the line below that. Okay, sure. So I'm going to return true and then close that. It's still within the function. Okay, right, so I think we finished with the maths and the setup and the complex numbers and all of this. So we're now going to add what I'm assuming is possibly the final function, which is to actually draw the thing. So we've got the function that's doing the maths, and now we're going to add in a function that actually draws the thing onto our current dark blue but blank canvas. So we need to loop through all of the x and y values, because I was wondering where the looping of x and y was going to actually come into the calculation, because at the moment we haven't sort of set, in that first loop we've written, first while loop, the iteration of f, we haven't really yet said what x and y are. So we're doing this in draw now. We're going to do it for like each pixel, I guess, basically, through the canvas, and then plug those values in to each loop to determine whether each particular point is or isn't in the Julia set. It's clever. So for var equals, no, for var, for the variable I equals 0 up to I less than the width, which we've input as the size of the canvas. And then we're going to increment. And then similarly, we need to run for on the j coordinate. So the I coordinate is being x, j coordinate being y. So for var j equals 0 to j less than height, I believe it'll be this time, and then we also do a j plus plus. So I'm guessing plus plus just adds 1 to the index based on what's being coded. So then within the loop, we're going to check, is it or is it not in the Julia set? So that calls the function we just written, the complex number one. So let's just put that in. So we're going to just now say if is in Julia set, if is in Julia set, and then the inputs there are I and j. Okay. And then what we're going to do, so if it's in the Julia set, then we're going to add a stroke. So I'm assuming that creates the point. And I'm going to guess we input the RGB values. Let's see. Right. So we're going to say stroke 255. So I believe that's for white. So I'm going to say stroke 255. And then point, I think, was what it says, is going to draw the actual point. So point at ij in white. So if it's in the Julia set, which means it's true, so if our complex number loop is in Julia set, this function we've created, if that's true, then it's in the Julia set, we're going to do a white point. If it's not, I'm guessing we're going to do a different color, maybe a dark color, or leave it blue. So the white points are going to be in the Julia set. We're going to set it to black if it's not in. So we're doing like an if is in the Julia set, white point, if it's not, or else is how we've coded it, then black. So else, and then from the else we want to do stroke 0, because I believe that's black, and then that will be that point. So else stroke point ij. Okay, it's time to test. So the instructor has made it look very easy, has just simply refreshed the page that's calling the code, and it just ran perfectly. So I'm really nervous about doing this, but let's see. So I'm just going to check I've got all my correct semicolons and things. I want to get this right first time. So we've got this function. Okay, so function for this, do this. Right, and then within that I said if that, do that. Else, I think, needs an open and close bracket. Let's just check. Pretty sure it will. Yes, it will. I had a feeling it would. So we need to open and close that thing. So the else one's closed. that other one has closed, or do I not close that one yet? No, I do close that one. So it's for, and then it was the if was there. So a lot of curly brackets I've missed. Okay, so for something, if, and then open up stroke, if, and then close that one, sure. So this is the part where you can all laugh at me. I just spent probably about 45 minutes trying to get this to work and trying to figure out why my code, which was literally line for line identical to the instructor's, was not producing a fractal. I had a colon instead of a semicolon. Absolutely ridiculous. However, I now see clearly very important. So I'd written a colon when it should have been a semicolon, and that just completely killed the code and meant I wasn't producing anything on my web page. I've now fixed it, and thankfully I'm getting my Julia set. So lesson very much learnt there, do not ever type a colon. So now the instructor is doing exactly what I thought they would and saying that we can modify the value of the constant c that we're adding to get a different Julia set. So I'm going to go in, play around with those values and see which cool ones I can get. So at the moment we've got 0.35 and 0.2. So if I change that to 0.5 and 0.25, see what happens. So if I now save this, and then it's going to reload my page for me, and let's see what we get. So we're gonna get taking quite a while, probably because I picked a really big canvas size. Nonetheless, we will get there. It really is taking a while. Probably a reason the instructor used 500 by 500. Maybe I'm going to change mine to 500 by 500. I'm definitely going to change mine. I'm still waiting. Okay, so I've changed it to 500 by 500. Let's see if it's any quicker. And I get a black square. Now that's interesting because black meant it was not in the Julia set. So I must have put those values too large so that almost basically every single point is now not in the Julia set. Interesting. So in that case, let's go back and slightly modify those values. So instead of being, so 0.5 I think clearly is too big. So if I do 0.15 and 0.25, so let's try saving that. And then let's reload the page. Thankfully going a lot quicker. Now I've changed it to 5. And I've got a kind of blob. It's not the prettiest. All right, let's play around with this. So if I do 0.15 and 0.05, what happens if I run that? So what have we got there? I'm adding on c is equal to 0.15 plus 0.05i. Ooh, it's kind of like a rounded type, almost like a circle thing. So I think the larger values were giving me cooler stuff. So if I went 0.41 and 0.05, let's try that. I wonder whether 0.41 is too big again. It might just be all black, let's see. Yeah, it's all black. Okay, so that's going to be too big. In which case, let's try like a 0.37 and 0.05. Let's try that. So again, save, reload the page. Again, it's all black. Interesting. So 0.31 and 0.05. What's that one going to be? There we go. Okay, I like this one. So it's got a nice little bit of spiral, a bit of curvature to it. Okay, this is cool. It's kind of like it's almost like a couple of S's merged together. It's very cool. So I'm going to stick with this. So playing around a little bit with those numbers, we've settled on a smaller canvas of 500 by 500, so as for it not to take forever to load. And I've currently got the real part of C as 0.31 and the imaginary part as 0.05. So a little bit more unique than what the instructor has. So that's the end of the second video. The longest one clearly contains the most content, where we've written the bulk of the code. We've talked about the maths behind the Julia set. So now the third video is entitled Coloring the Fractals. So this is what I'm excited about. I think I've got a nice shape. I like the shape that I have. Now we're going to add some colors and really turn it into a piece of art. So this is interesting. We're apparently going to decide on the color of each pixel based on the number of iterations required before it became true or false, which is quite an interesting way of doing it. I was wondering how we were going to get lots of different colors in there. So this seems as good a way as any. So let's see how it works. So what we're going to do is go back to our draw function. We're apparently going to remove this if loop, and then we're going to say, just fully set the stroke, the color, the stroke function. So that's going to now be get, oops, that's now going to be get Julia color, and it's going to have this input of ij, okay, and then we're going to do the point ij, right, and semicolon. So it should now be grey, is what I'm being told. So let's save this, and then let's run this whole thing. I'm hoping for a grayscale fractal. Yes, it's a grayscale fractal. It's terribly boring because it's literally one block of grey and black. But it's a fractal and it's not just black and white. Okay, interesting. Right, well, let's continue. So we can actually use the stroke to be RGB. So then we'll get a red only fractal. So let's just check that's gonna work. So this should come out as red. Let's see if I've understood correctly. Yes, red. Okay. Let me see if I can get it to be blue and green, shall we? Okay, so if I make red 0 and then green. So this one should be green. Let's see. Let's save that and then let's run. It's green. Okay, and just to complete the set, let's get a blue one. Okay, so that would be the third color. Would be that. Righty, so let's save that and let's run that one. It's blue. Okay, I think the green was the best, but I'll put it back to red because that's what the instructor had for the time being. All right, good. See, this is nice. So in order to get more detail in the fractal, we need to run more iterations. So it's saying we're going to increase, so at the moment we're doing 100 iterations. So we're saying if we change that to be 500, then we'll get more detail. But, and this is really important, if we're using the number of the iteration as the input for the RGB color scale, it has to be between 0 and 255. And at the moment, it could go up to 500. So clearly we have to scale that to make sure the input we're using to select the color is in the required range. I like that. So let's see how we're going to do it. In order to do that, we use something called a modulus function, which is where I just add a percent of 255. So I think that's just then telling it to scale things appropriately, I believe. Okay, so let's just try that. So I'm running now 500 times. I should get something that's red, and it should have the correct scale on the color and actually work. Let's see. Nice, it's a lot brighter, which is good, but there's still not that much detail. If there's that much going, I might have to change the value of C. Okay, right, so I'll go back to the instructor's values just to make sure, because there's more detail in the one that they have. So let's go back then. So 0.285 and 0.01. So if I go in and add 0.285 and 0.01, and then let's run this, and now I should get this lovely detailed red kind of fractal. Yes, I've got a lovely detailed red kind of fractal. Okay, this looks really cool actually. I am going to definitely change the numbers at the end though. Got to get something unique. Intriguing. So we're going to change the color mode apparently. So in the setup function, right, function setup, so after no loop, it's saying here that I can change color mode, and I want to change this to be HSB, which I believe stands for hue, saturation, and brightness. Okay, so our limit is now up to 360 for the hue, so we're going to have to change that. And then we're saying to go for 100 and 100 on the brightness and the saturation. Okay, so if I run this, see what happens. Ooh, I got a red background and we've got all kinds of yellow and green and blue. It's pretty cool. It's pretty cool to be fair. Okay, I'm not sure about the bright red, but otherwise I quite like that. Right, so let's try the final lesson, which is called panning and zooming. So I'm guessing we're going to create a more intricate, bigger fractal, and we're going to zoom in and move around and create a nice little animation. That's what I'm hoping. Let's see. This is interesting. So the instructor discusses the, let's call it the naive approach of just, which I'll admit I thought about, was just creating a better resolution, bigger fractal. However, what we're actually going to do is multiply our values, sx and sy, by some zoom factor. So it's a completely different way, and apparently is more CPU friendly. So it's very neat. We need to create that variable. We are going to put it up here. So we're going to create var zoom factor. And we are going to put that equal to 0.5 semicolon. So we've created the zoom factor variable. So now we multiply the var sx and var sy. So I want to do this times zoom factor, and then semicolon, and then this one times zoom factor, semicolon. All right, let's try this. So if I run this, I think this will be twice as big, at least the fractally bit itself, but we'll see. Yes, we're zoomed in. Okay, so I think we've zoomed in twice. I can see all kinds of fun little blue dots actually starting to appear in some of these pieces. So already this looks so much better. So we're playing with different amounts of zoom. So for example, we were told to try 0.1 as the zoom factor. So this is now going to be 10 times zoomed in. So when I run this, you'll see that we're actually too zoomed in, or we've zoomed in so much that, in the words of the instructor, the interesting parts of the fractal are no longer on the page. They're no longer inside our canvas size, which is true. So what we want to do is actually shift and move around the central location. So we're going to do this creating these offset variables. So let's see how that works. Okay, so we're going to create these additional variables. So we're calling them var offset x, and we're going to set that to be minus 0.5, was that? And then we'll create var, same thing, offset y, I'm going to call that minus 0.5. So this is going, I think, to the right and down, I believe. Let's see, the negative ones. And then we just have to add them to the values here. So plus offset x, and semicolon, and then plus offset y, semicolon. Okay, so let's try. So it should be a different location, that's the key thing. Yes, different location, it looks really cool. Okay, wow, that's amazing. So apparently we can actually go 100 times zoom. I'm intrigued as to how far this can go. So the instructor has done 100, so I'm going to try that. So let's open up code again. So if I change the zoom factor to 0.01, then this should now be 100 times zoom. So I reckon we're going to get in on these blue bits. Let's see. Yeah. Oh, the bit at the top, that's what I want. Okay. So there's a little bit in the top left, like purpley blue. So I want to kind of get, so if I bring it down more, let's see if I can make this work. So if I do the y offset, so instead of being minus 0.5, if I made it minus 0.9, let's see what that does. I seem to be way too far now. Well, interesting. And let's try and zoom again. So let's go to 1,000 times zoom. Let's see if that's actually possible. It is possible, it's just not really that interesting. Okay, well, played around with it. All right, so let's see what the final thing the instructor's gonna do is. So the final task, as I expected and was gonna do anyway, is of course to create your very own fractal. So I'm gonna play around with the C value, I'm gonna play around with the zoom, I'm gonna play around with this offset, and I'm gonna create my own unique pieces of artwork. Oh, now this is cool. Okay, right, this is really cool. Okay, I like this one. So we're gonna go with this one. I'm maybe gonna pump that brightness, as much as it pains me, back up to 100 just to get the nice bright color. So I'm gonna have the painful red again, but I want the bright colors. Okay, so we've got the nice bright colors. Right, now this looks really, really cool. So I think what I'm gonna do is I'm gonna zoom in 100 times. So let's do that and see what that looks like. And it's just pure red, okay. So I clearly need to offset. So let's try minus 0.5 on both of them. So based on the suggestion from the instructor, so let's try that. Oh, I can see something over to the left. So if I want to bring that in, I need to lower, maybe raise that one to 0.6. Let's try. So I've changed it to minus 0.6. So I think this will shift to the right, but we'll see. It has, but maybe too much. Very interesting. So let's, what if I did 0.55? That's the one. I think that might be the one. That's very cool. All right, I'm going to go with that. I have settled on my final piece of art fractal I'm creating. It looks pretty damn cool, I'm going to say. All right, it's definitely not my tattoo. I don't know how I'm even going to attempt to get that one, but this looks damn cool. Right, so let's see what's going on then. So I think I finished all the videos, and there we go. Congratulations on finishing your class. Awesome, that was a lot of fun. So there you have it, my very own piece of mathematical art based on fractals, which was created by following the Skillshare course, Create Stunning Fractals with JavaScript and P5.js. I now know what all of those terms mean. Remember, if you want to try this course for yourself or any of the other amazing courses available on Skillshare, then you can join using the link in the video description or with the code TomRocksMaths to get a 1-month free trial. Thank you everyone for watching. Please do remember to subscribe if you've enjoyed the video, and I'll see you all soon. Take care.